Assalamualaikum and hi everyone. So today we're going to discuss about my final assessment for this semester. Yeah, let's start with question number 1. From the question is a high pass filter and the circuits will looks like this. So for the calculation, omega is equal to 2 pi over t and the t is already given in the question, which is 125 millisecond. So the omega will be 2 pi over 125 times 10 to the power of negative 3, and you will get 16 pi rad per second. For the V output is equals to R over R plus 1 over J omega C. And then you should multiply it by V in. For the V output over V in is equal to J omega CR over J omega CR plus 1. And then omega is 16 pi. We should assume that the R is equal to 100 kilo ohm. And then the V output is already given 3 voltage. And the V input is also given, which is 5 voltage. And then we should just insert the value in the equation, but the equation might be different because we don't have G anymore. So 3 over 5 is equal to 16 pi times 100k times C divided by 16 pi times 100k times C square, and then plus 1, and then you'll just square root the all of the values, and then you will get 1 plus 16 pi times 100k C square is equal to 7.0184 times 10 power of 13 C square. And then you simplify it, you'll get 1 is equal to 4.4918 times 10 power of 13 C square. And then your C will get 0.15 microfarad. And then let's continue with the LT-SPICE simulation. First of all, you should put the V, which is the voltage, and then you just connect it with a wire and put the capacitor. The capacitor should be on the top because this is a high pass filter, so yeah, the capacitor should be on the top. And then you just put a resistor there and just connect it with the wire again. And also don't forget about the ground, because if you want to do the simulation, then there must be a ground in the circuit. Okay, next, I put the V output and the V input there to show you guys which one is for the V input and which one for the V output. Yeah, it's actually not important, but I just do it to make it look more understandable. And then we should just change the value just like we calculated before, which is the C1 should be 0.15 microfarad and the resistor will be 100k ohm. Okay, so before we run the simulation, we should do the setting for the V, which is a sine. And yeah, DC offset should be 0, amplitude 5, frequency 8, delay 0, theta 0, and the degree is 90. And for the stop time, it will be 250 milliseconds. So let's do the simulation, and yeah, this is how it looks like. Okay, so let's look at question number 2. As you can see, it's a band stop filter, so this is how it looks like. Okay, next, for the calculation, the FL is given 1 kilohertz, FH is 10 kilohertz, and the FC is 5 kilohertz. It's all given in the question. And then we just assume L, which is the inductor, L1 is equal to L2 is equal to L3, which is 100 millihenry. So it will be easier to calculate. So first, FL is equal to R1 plus R2 divided by 2 pi L1 from the circuit before. And then 1 times 10 to the power of 3 is equal to 2R over 2 pi times 100 milli, and then I just assume that R is same, so R is equal to R1 is equal to R2 is equal to 314.2 ohms. And then next, for the high frequency, FH is equal to R3 over 2 pi times L2 plus L3. Then you just simplify it and insert the values, and then you will get 0.24 L2 plus L3, and then your R2 will get 12.57 kilo ohms. Okay, let's move on to the LTSpice simulation. Just like before, we should just put the V first and then connect it with wire. And yeah, just like the drawing before, just like I draw before, we put 2 resistors on top, and then the L, the inductor, and just connect it. And for the bottom, you put 2 inductor, which is a vice versa from the top, which is an L2 and L3. Okay, you just what we call, just rotate it, because it's not always vertical in landscape. And then you put the resistor there, resistor 3. And yeah, don't forget about the ground, because if you didn't put the ground, then your simulation will not occur. And then you just go to the setting for the AC circuit, and you just put AC1 for the 2-phase. And yeah, don't forget to insert the value we calculate before, which is all the L is just the same, 100 millihenry. I'm sorry I didn't put the unit there, but it should be H for Henry. Yeah. And R3 will be 12.57 kilo ohms, and L1 is equal to L2 is equal to L3, and for the R1 and R2 is the same, because I assume it to be the same, which is 314.2 ohms. Well, I should have put the unit also, but I didn't put it. Yeah, and then yeah, you should do the setting before you run the simulation, so that it will be smoothly simulate. Okay, you guys should choose AC analysis, and the type of sweep is a decade, and number of points per decade is 100k. And for the start frequency, I choose 10, and for the stop frequency, I choose 1000k. Okay, so don't forget to put the V input and the V outputs. Okay, next let's run the simulation. And yep, this is how it looks like. So yeah, that's the end of our discussion today. So thank you everyone. Bye bye.